Start this class. In last class we cover the linear transformation, which type we have some transformation and some vector space, then idempotent, nilpotent, and some linear independent set. Okay. Today we start conversion of transformation into a matrix. So first we need what is the coordinates for any matrix. We required coordinates of any vector. What is coordinate of vector? Rohit, Bakul. What is coordinate of a vector? Coordinate. Anyone have idea about coordinate? Let some vector x from a vector space Vn over f, right? So if Vn over f is a vector space of n dimension, then we know B must be a basis such type B has n number of elements x1, x2 and so on xn. This is an ordered basis of Vn, right?
Yes, sir. x1
So
c1 x1
yes,
plus x1 c1 x1
then x must be a linear combination of elements of basis
basis, yes. c1
or
c2
some constants as
yeah,
ai's comes from field.
field.
Then we denote x corresponding to B basis, right? So we get a vector that is a1, a2 and so on up to an. This is a column vector. So we
Yes,
get
sir.
this is a y such that y transformation must be in Fn, right? So this y corresponding to some basis, fixed basis, we get different y's. If we change the basis, then we get different vector or similar. Like we say, if we have a vector space R square, then any vector of a comma b type, if we define basis 1 0 and 0 1, then you get different coordinate. But if we define 1 0 1 1, then you get different coordinates, right?
Yes, sir.
If we change the basis, then coordinates change. So this vector is called coordinate of that vector. This is called the coordinate of x with respect to an particular basis, that is ordered basis, right?
Yes, sir.
Basis b. Now if we say a transformation t with respect to some basis, we fixed a basis b, right, for Vn over f to Fn over f, then you get with, yeah, we define a map t of x with respect to basis, particular fixed basis, to coordinates of the vector with respect to basis b, right? This is a transformation or not? if we define V and F to F and F, then TB is a linear operator or not?
Linear operator.
Because of Vn over F, Fn over F are isomorphic. So
Hmm.
TB is a linear operator, right?
Yes, sir.
And V here Vn over F must be isomorphic to Fn over F. If we say this linear operator is non-singular, then this linear operator is called, if an linear operator is non-singular, then TB is, if we define a linear of isomorphism from same group to same group, then you say that is automorphism, right?
Yes, sir.
Okay. Now we define a transformation Vn over F to Vm over F and BB a basis x1, x2 and so on xn. This B is basis of V, and we let some B prime is equal to x1, sorry, we take different y1, y2 and so on ym are bases of, Vn and basis of Vn and Vm respectively, right? If we fix the basis, now if some x belongs to Vn over F, this implies that Tx must be in VMF or not. Now we define image of x is equal to linear combination of all some beta I yi, right?
Yes, sir.
Sir.
So T of x with respect to B prime is equal to beta 1, beta 2 and so on beta m. This is a m cross 1 column, right? If we have a x. So if we say x1 is basis, then all of you know if x1, x2, xn are li, then image of these vectors may be li or may not be li.
May be alive.
May be li. We say image of T of x1 is a linear combination of must be yi's, but all xi's, image of all xi's is the linear combination of all yi. So we say this is linear combination such that a11 y1 plus a21 y2 plus and so on am1 ym, right? Similarly, we consider for x2 a12 y1 plus a22 y2 and so on a m to ym. Similarly, if we take t of xn, this equal to a1n y1 and summation a2n y2 and so on up to a m to ym, right? All things are clear?
Yes, sir.
Yes. So we say in general image of t of some x r corresponding to some basis b prime. Then we get some vector a1r, a2r and so on a mr, right? Then the matrix of this linear transformation with respect to b and b prime is given by given as t with respect to basis. First b is basis of domain and b prime basis of codomain or range. Maybe b and b prime are same, maybe different, right? This is a matrix of m cross n order such that we collect all the coordinates of bases, right, with corresponding b prime. Okay, all things are clear. These are all columns. So if t is not 1 1, then this matrix determinants is 0 or not?
Yes, sir.
Must be 0 because of these columns are LD. If t is 1 1, then all columns are Li. And you know linear combinations are different for every vectors, then all row are different. Now we take some example for this. Let some t from r square to r square. Now define some transformation v t of xy is equal to x plus y comma x minus y. Now we define b1 is equal to 1 0 and 1 1 basis of domain, right? We say this is x1, this is x2. Now we define b2 0 1 1 0. Both are different.
Yes, sir.
Find the matrix.
Yes, sir.
How we find matrix? First we need to find image of basis, right? So t of x1 that is 1 0. So t of 1 0 image is according to this transformation 1 1, right? So this 1 1 you write linear combination of b2. How you write? 1 into 0 1 plus, yes, 1 into 0 1. And now you find image of x2, that is t of 1 1. This equal to 2 comma 0, right? So you can write 0 times of 0 1 plus 2 times of 1 0. So hence the matrix is T with respect to B1 B2 is, now you write the columns, coordinates of T x1 is 1 1 and coordinate of for T of x2 is 0 2. So this is the matrix. This is required matrix or not?
यस सर. सर ये आपने टी एक्स टू कैसे किया?
Transformation. We have x2 1 comma 1, put 1 plus 1 is equal to 2, 1 minus 1 0. So T of 1 1 is 2 comma 0. Then 2 comma 0 write in linear combination of y1 y2, right?
यस सर, आ गया.
Okay.
सर इसमें पहला एलिमेंट को, सर दोनों बेसिस की रिक्वायरमेंट क्या है? क्या एक बेसिस से नहीं हो सकता? जैसे पहला एलिमेंट,
Yes, yes.
पहला इमेज x1 को जो मिला है सर, उसको b1 के लीनियर कॉम्बिनेशन में जो कोऑर्डिनेट कोरस्पॉन्डिंग मिला है उससे एक्सप्रेस किया है. फिर सिमिलरली x2 को मतलब b2 से कॉम्बिनेशन में एक्सप्रेस किया है. तो मतलब ऐसा करना
Okay.
क्या है?
We take images of B1 which is basis of domain, right? And we have B2. Then that image we write in linear combination of B2. Maybe B1 and B2 are same. मीन्स आपको जो डोमेन के एलिमेंट्स हैं उसकी बेसिस होंगी, उनकी बेसिस की जो इमेज है उसको जो हमारे पास बेसिस दूसरी दी गई है उनके लीनियर कॉम्बिनेशन में लिखना है जो कि इमेज आएगी उसको. ठीक है ना?
सर ये ऐसे नहीं होता टी एक्स टू वाला, 2 इंटू में ये ब्रैकेट में और ये 0 1 प्लस में 0 1 एंड 0.
आप B1 के लीनियर कॉम्बिनेशन में लिख रहे हैं क्या?
नहीं, b2 के,
किसको?
ये टी एक्स टू को.
टी x2 क्या है? 1 1.
यस सर.
उसकी इमेज क्या आएगी?
2 0, तो ये सर इमेज आ गई.
ये आ गई. इसके बाद B2 का एलिमेंट क्या है? 0 1 1 0 है ना?
यस सर.
तो एक आपको ऑर्डर फिक्स करना पड़ेगा ना.
जी सर, फर्स्ट टाइम में तो इसके 2 है ना, पहले 0 से पहले 2 0.
2 तो है, आप ऐड कीजिए. राइट हैंड में जो लिखा है क्या यही आएगा या डिफरेंट आएगा? वहां 2 पहले है उसका, ये मतलब नहीं कि पहला कोऑर्डिनेट 2 आएगा.
अच्छा.
वेक्टर हमारे पास 0 1 है ना.
हाँ.
पोजीशन चेंज कर देंगे तो डिफरेंट हो जाएगी मैट्रिक्स. ये हमारे पास
ओके
ऑर्डर
सर.
बेसिस होती है. ठीक है ना? यदि उनका ऑर्डर चेंज कर देंगे, जो वेक्टर्स हैं हमारे पास बेसिस में, यदि उनका ऑर्डर चेंज कर देंगे तो मैट्रिक्स हमारे पास चेंज आ जाएगी. बट उसकी रैंक वो सब सिमिलर हो सकती है, बट वो मैट्रिक्स डिफरेंट होगी. राइट?
यस सर.
क्लियर है?
यस सर.
किसी को कोई डाउट है?
नो सर.
ओके. Now if we have a matrix, if we have a matrix T matrix of transformation T with respect to B1 and B2, right, is equal to some A which is of order m cross n, and T be a transformation from Vn to Vm. Then some x belongs to Vn, A of Ij product with x with respect to B1, this equal to T of x B2. This is right or wrong?
Right.
Right, clear? If we have a matrix A and for particular transformation T with respect to B1 and B2, if we multiply the coordinates of B1 with respect to B1 of x, then you get the image which is linear combination of B2, right? Because of T defined on the B1 and B2. Then if elements belongs V1, Vn, then image belongs to Vm. B1 basis of Vn and B2 basis of Vm. This is definition, right?
Yes, sir.
Okay. If B1 is basis, have B1 has n elements and B2 has m elements, y1, y2 and so on ym. Then T of x with corresponding to B2 is equal to some beta 1, beta 2 and so on beta m, transpose or not. So this implies that T of x is equal to beta y1 plus beta y2 plus and so on beta m ym. This is right or wrong?
Right, sir.
Right.
Right. Now we have a question for you. You find, let T be a transformation from R2 over R2 over R to R2 over R. And we define B1 is equal to 1001 and B2 is equal to 1110. Then T of xy, define any transformation from R2 to R2. Define any transformation
Yes, sir.
according to you. Give me a transformation.
X square plus y square.
This is
X square.
transformation.
No, sir.
Sir, x plus y into max minus y.
Okay, this is similar. We say x and x plus y, right? This is also a transformation.
Yes, sir. X
Yes.
plus y, x minus y.
Okay, you write different transformation as, okay. Then you find your task. Find t with respect to b1, right? Same basis. And with respect to b2, right? You need to check these matrices are similar or different, right? T with respect to b1, b2 and T with respect to b2, b1. You can find all the four matrices.
Yes, sir.
Try to find, right? I'm not solving this question. Okay.
Okay, sir.
Okay, sir.
Now you have some transformations of reflections. All of you know study reflection in class 12th or 10th. All of you know reflection. We say T of AB is equal to some x comma y, right? Now, first, reflection, we say reflection in the line
Sorry, reflex symmetric transitive
no no
equivalence.
no no not reflection,
Yes, sir.
we say reflection. You know reflection?
Sir, reflection along x-axis, reflection along y-axis.
Yes, right. So we write reflection along the line x-axis. What is transformation? If we say we have elements a comma b, then where a comma b maps?
0, B.
Yes,
0, B.
0 comma b with respect to x. How? You say
A, 0, A, 0.
I'm not saying on the x line, right?
A comma minus b, sir.
Yes, because of you telling me the on the y x axis, right?
Okay, sir. Yes,
This
yes.
is along. You let x axis is a mirror. If we have a comma b point, if x is a mirror, so you have a you get a point which equidistance from x axis such that this points also, if we have this point is b distance from x axis, so here you get b distance from x axis, both are equidistant, right? So you get a comma minus b. And what is matrix of this? Anybody know? Standard matrix.
Skew
This,
symmetry.
yes.
Skew symmetry. मैट्रिक्स का टाइप पूछ रहे हैं
No,
सर
no. I
क्या?
am not saying skew symmetric, symmetric not condition. I want matrix, elements of matrix. I want what is elements of this matrix with this standard basis 1001, right?
Yes, sir.
Sir, 1001. 100 minus 1.
100 minus 100, right? Okay. Next, reflection along the line y-axis. Then what is coordinates? What do you get? T of AB.
माइनस ए कॉमा बी,
Right. Then you get the matrix of this.
माइनस वन कॉमा जीरो जीरो कॉमा वन,
-1 0 0 1. Reflection along, but reflection about, not along. Okay. Reflection about the line y is equal to x. बताइए.
सर मैट्रिक्स बनेगी 0 1 और 1 0।
Okay. 0 1 1 0. सभी के सेम आ रही है मैट्रिक्स. And what is image of AB?
बी ए,
BA, right? Change the position. Now next, reflection about y is equal to minus x. Reflection about y is equal to minus x. What is the image of
बी,
AB? This
बी माइनस ए,
B minus A. This is right or wrong? Right?
यस सर,
यस,
What is matrix? Reflection about origin.
सर 0 माइनस 1 और माइनस 1 0।
Reflection about origin. T of AB is equal to minus A comma minus B, right? यही होगा ना? बताइए या नहीं होगा?
सर ओरिजिन पे तो 0 0 होता है।
नहीं, ओरिजिन पे 0 0 होता है. ओरिजिन को मिरर आपको एज्यूम करना है.
अच्छा तो
Take some point,
यस,
then this is a mirror. So here we have image, right?
यस सर,
So every element of first coordinate map to third coordinate. Then change sign of A and B both, right?
यस,
And all elements of second coordinates this maps to fourth coordinates, and all elements of fourth coordinates maps to second coordinate, and all elements of third coordinates maps to
फर्स्ट,
first coordinate. क्लियर है?
यस सर। सर ये मैट्रिक्स कैसे कंस्ट्रक्ट करते हैं?
अभी मैंने आपसे बोला कि स्टैंडर्ड बेसिस के करस्पॉन्डिंग जो भी रिफ्लेक्शंस है इन 2D, दिस इज ट्रांसफॉर्मेशन इन R2 R2, and we say standard basis B 1001, right? then you find T of BB, right? So what is image of 1 0 in for first about x-axis? If we define T AB is equal to A minus B, so this equal to 1 0, and T of 0 1 is equal to 0 minus 1. Then you get matrix is 1 0 0 minus 1, right?
Yes, sir.
Clear है? You have any doubt?
No, sir.
No. If we say we have a point, you rotate by angle alpha, then what is transformation? Anti-clockwise direction. Next, if we say a point, we say T of AB is equal to some xy, where x comma y is obtained by rotating A comma B in anti-clockwise with angle alpha. What is transformation? What is transformation? You say y is equal to alpha x and
Alpha is slope.
alpha is,
Slope.
this is transformation. I say what is xy? You say x comma alpha x. This is transformation. T of xy. If we have a coordinate, right? And we say point A comma B in somewhere. We say A comma B point is here, right? This is my point A comma B. And after rotation anti-clockwise, go to position some C comma D, right? Right? Clear? So in initial, you have any point make some angle theta or not?
Yes, sir.
We rotate angle with angle alpha, right?
Yes, sir.
but length of this is same. If we say this is r, so this is also r. Distance from origin change or not?
Not change.
Not change, right? But perpendicular is changed. This perpendicular means height is changed, right?
Yes, sir.
But length is not changed. Argument is not changed. Now, so we let t of a comma b is equal to x y, right? So we assume that a is equal to some r cos theta, right? And b is equal to r
Sin theta.
sin theta. Anyone have doubt?
No, sir.
Then what is x and y? So x is equal to r cos new coordinates. Sorry, we write here CD. This is not CD. We write xy, right? So for xy, we have angle is theta plus alpha, right? New angle.
Yes, theta plus में alpha, sir.
So theta plus alpha, r cos theta plus alpha, and y is equal to r sin theta plus
Alpha.
alpha. Now we open this, then we get x is equal to r
R cos
cos
theta.
theta
Cos alpha.
cos alpha
My
minus
R sin alpha. Sin theta and sin
Sin
alpha.
theta, sin alpha.
r sin theta sin alpha. Then you have value of r cos theta with
Yes, sir. A.
a. Then we put
A cos
x
alpha.
is equal to a cos
Alpha. My
minus
B sin
b
alpha. Sin alpha.
sin alpha. Then you get image of first coordinates. Similarly,
Y.
y is equal to
Y is equal to
a
A
sin alpha
minus B
plus
plus, plus B cos alpha.
b cos alpha. So hence transformation T of AB is equal to A
Cos alpha.
cos alpha minus B
Sin alpha.
sin alpha comma A sin alpha plus
Cos alpha.
B cos alpha, right? So this is transformation where we rotate some point in anti-clockwise direction with angle alpha.
Yes, sir.
Clear this transformation?
Yes, sir.
Then you find the matrix of this transformation.
Yes, sir.
Now we try to find with the standard basis, right? What is standard basis? 1001.
Yes.
So let b is equal to 1001, right? Now we find image t 1 comma 0 is equal to, okay, we copy the transformation first. 1 minute. This is transformation. So image of 1 comma 0, this is transformation. Using this transformation, image of 1 comma 0 is cos alpha comma sin alpha.
alpha.
Then you get coordinates cos alpha 1 0 plus sin alpha 0 1, right? And image of t of 0 1 is equal to minus sin alpha cos alpha, right, is equal to minus sin alpha 1 0 plus cos alpha 0 1. Then matrix with respect to basis B is equal to cos alpha sin alpha sin alpha cos alpha. This is rotation matrix with angle alpha, right?
स्वेन के साथ कोफिशिएंट भी है ना ए बी,
Yes,
वो
same B.
वही मल्टीपल्स में,
Yes,
वो मल्टीपल्स में आएंगे नहीं आएंगे?
क्या आएंगे बोले आप?
वो जैसे कि कोस ए कोस अल्फा 0 1 0 प्लस में ये वाला ए साइन अल्फा 0 1,
ए साइन अल्फा 0 नहीं, वो तो हमारे पास क्या है 1 0 0 ने उसके कोऑर्डिनेट्स लिखेंगे ना।
नहीं सर इनके मल्टीपल में है, जैसे कि अपने पास टी ए कोमा बी इज इक्वल टू ए कोस अल्फा माइनस बी साइन अल्फा।
हाँ, इसी का मैट्रिक्स है ये, इसका मैट्रिक्स यही बनेगा, ठीक है ना?
यस।
देखिएगा क्यों बनेगा, यहाँ पर यदि a कॉमा बी का प्रोडक्ट कीजिए राइट हैंड से तो आप देखिएगा यही मिलेगा, आपको मिलेगा। राइट से a कॉमा बी जो वेक्टर का प्रोडक्ट कीजिए सेम मिलेगा टी ऑफ ए बी।
यस सर।
यही तो प्रॉपर्टी होती है, मैट्रिक्स में प्रोडक्ट करें हम ट्रांसफॉर्मेशन से निकालें इमेज सेम आती है ना। Now you remember that a2 power n is equal to cos n alpha minus sin n alpha and sin n alpha cos alpha n alpha, right? आप इसका स्क्वायर कीजिए, आपको इसी तरह से मिलेगा 2 अल्फा 2 अल्फा, ठीक है? क्लियर है ना?
यस सर।
Yes, some most important point. If we say some u which is non-zero vector belongs to R2 or R square, then what is angle between u and AU? What is the angle?
सर 0 डिग्री।
Not alpha. Is always alpha. Okay.
सर u इज वेक्टर ना,
U any non-zero है
तो अल्फा इज कांस्टेंट सर।
alpha. Yes, alpha is fixed angle.
एंगल ओ
Angle, not constant. Alpha is angle. Because of here we use an alpha is an angle.
Okay, sir.
If we multiply this vector in matrix, then you get the image. Remember this. If you have a vector u vector is point in R2. If you multiply u by a, then you get image of a corresponding T transformation. So this transformation is all about angle.
Yes, sir.
So what is angle between image and initial point? Exactly alpha, right?
Yes.
If you multiply again and again a, means if we say angle between u and alpha to power n u, here second point, if u is a non-zero vector from R square, then angle between u and a to power n u is exactly n alpha, right? Image of image, then you get every time you get in addition and alpha angle, right? If we say this is a transformation, you have some point, this makes angle some any angle theta or any angle, I don't know, this point AB, then you operate with a, then you get a of this is u, then you get au, then this is angle alpha. If you operate second time, then you get again a square, and a square and au, between a square and a is angle alpha. Then from initial point to end point you get sum of angles. This is clear?
Yes, sir.
Okay. And this matrix A is orthogonal matrix also, right? Or not?
Orthogonal matrix, sir. Yes.
Orthogonal matrix. Now we ask one question. We say if some vector u is equal to 1 comma 3 and A is an orthogonal matrix with trace of A is equal to 1. Clear? Then the angle between u and a square u is, what is angle? Option A pi by 3, option B pi by 2, option C 2 pi by 3, option D pi by 4. What is correct answer? If we ask in general this question, so this is tough question or easy question? What is answer? Anyone get answer? So we know a general orthogonal matrix, right? We know orthogonal matrix. A is equal to cos alpha minus sin alpha cos alpha. This is general orthogonal matrix, right? Because of for every alpha this is orthogonal. This A is orthogonal for every alpha, not even particular alpha, right?
Yes, sir.
So you get how many matrices? Infinite matrices.
Yes, sir.
So this is general form. Every matrix is similar to this matrix with some alpha, right?
Yes, sir.
So what is trace of A?
Two
1.
cos,
What is trace of A?
two cos alpha.
Here trace of A is given 1, but
Two
from
cos
this
alpha.
this 2 cos alpha, right?
Yes, sir.
So this implies that
Two cos
2
alpha
cos
square
alpha
one.
is equal to
One.
1. 2 cos
5
alpha
and
is equal
3.
to,
One alpha
Alpha
five
equal to
is
5 and 3.
then alpha is equal to minimum angle is pi by
3.
3. Now you know angle between A and U is alpha, and between U and A square U is 2 alpha.
yes, sir.
What
Yes,
is
sir.
angle?
Two alpha one is 5
2 and 2. 2 alpha by 3.
U and A square U is equal to 2 alpha, which is 2 pi by 3. Hence answer is
2 5 8.
option C. Now you get the answer. Clear this question?
Yes, sir.
Sir.
Now you find angle. You solve this type of question in any exam.
Yes.
If you get some vector,
सर ये
suppose
आपने टू कोस अल्फा कैसे किया?
I tell you
Trace. Trace
angle
of
between
matrix.
U and A to power nu is n alpha in general. Here A square is U is t square of U, image of image, right? So if we take image of image, then what is angle? First time you get alpha angle between image and vector, then again you get alpha angle, then overall angle is 2 alpha, right?
Yes, sir.
So you use U, any use of this vector, any use of vector U,
No,
not
independent.
independent. If you not given any vector U, then you also get the answer. But there is some condition here, you get only U is non-zero.
Yes, sir.
This is clear. If U is 0, then you get only point, not any angle. Then how you define angle? Not define. This question is clear.
Yes, sir.
Yes, sir.
Okay, now continue with class or stop here. Now some more conditions. A is a matrix cos alpha minus sin alpha and sin alpha cos alpha. We see this matrix belongs to SL2R. This is correct or not?
Correct.
Correct. Also this belongs to GL2R
Yes,
Yes,
sir.
sir.
because of determinants is
Non-zero.
1.
Yes, sir.
We see for different alpha you get whole SL or not? You try, okay, for this. What is a to power n?
Cosine alpha minus sine
You
alpha.
get some questions in the examination for this concept in maybe IIT ZEM in previous year. If we say alpha is equal to 2 pi upon n, then a is equal to cos 2 pi by n, sin 2 pi by n minus sin 2 pi by n and cos 2 pi by n. Then a to power n is equal to
Identity matrix.
identity matrix. All of you know this concept. If we say here, we say some question. Let a matrix A, right, sin 5 pi 1 pi by 6 pi by 6, okay, and sin pi by 3 and minus sin pi by 3 and sin pi by 6 and a to power n is equal to identity. Then what is value of n? बता सकते हैं क्या?
Yes, sir.
This type of question is a comes in some exams, right?
3, sir.
Yes, sir.
3,
Not 3.
not 3. You can't find by multiplying, right?
Yes, sir. 5 multiply.
No, you multiply a by a, then you get, this is very
I
rigorous process.
ask. Sir, please repeat.
I say if you multiply in generally by you find a square then a cube, then
Yes,
this
sir.
is very rigorous process. Maybe you not get after 5 power 6 or 7 power. So this is very lengthy question, right?
Yes, sir. Yes, sir.
You use this concept, above concept.
Aims on 3D Moivre's theorem. A cube করলে identity আছে.
A cube is equal to identity.
Yes, sir. Sin pi by 2 minus sin pi by 2 1, sin pi 0, আবার sin pi 0, sin pi by 2 1 identity.
Here we write a is equal to this sin pi by 6. We write cos pi by 2 minus pi by 1. We write sin pi by 2 minus pi by 3. This is correct.
Yes, sir.
Okay, this sign is pi by 3 and here sin pi by 3 and here we write sin pi by 2 minus pi by
3.
3. Then what is sin 90 minus theta, cos theta?
Cos pi by
So you get cos pi by 3
half.
sin pi by 3
minus sin pi by 3.
minus sin pi by 3. This is similar
Cos
to
pi
a
by cos pi by 3.
cos pi by 3. This is similar to a, here alpha is,
Yes, sir.
here alpha is
Pi by 3.
pi by 3.
5 by 6.
Pi by 3. So we equate with 2 pi by n for some n. Then power n is identity. What is n?
N is here 2. 6. This one.
N is 6,
3.
right?
Sir, put n equal to 6. A is not identity.
Not identity.
A to the power 6. A to the power 6 করলে sin 6 pi by 6 মানে sin pi 0 minus
सर
sin 2 pi sin 2 pi or sin pi.
This is right or wrong?
सर इसमें मुझे समझ नहीं आया माइनस क्यों कर रहे हैं सर, मल्टीप्लाई नहीं करेंगे सर, ए टू दी पावर एन एन टाइम्स।
हाँ क्या कह रहे हैं? हेलो,
सर ए टू दी पावर एन साइन एन टाइम्स हो जाएगा ना, उसका एंगल्स में मल्टीपल्स हो जाएंगे ना सर।
हाँ हाँ,
तो मैं ये कह रहा हूँ कि अगर ए टू दी पावर 3 कर लेंगे तो एंगल्स का मैग्नीट्यूड में 3 टाइम्स सारे मल्टीप्लाई हो जाएंगे।
लेकिन जो आपकी इनिशियल ए गिवन है वहां पर ये प्रॉपर्टी सेटिस्फाइड होती है क्या? एन मल्टीप्लाई हो जाएगा? वहां नहीं होती है। जो आप ये ऑर्थोगोनल होनी चाहिए मैट्रिक्स, तब ये कंडीशन सेटिस्फाइड होगी।
सर फिर तो n कट ही जाएगा।
ये इसमें सेटिस्फाइड होगी जो आफ्टर मैंने सॉल्यूशन एन ए फाइंड किया है।
ओके सर।
इनिशियल में साइन 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 गिवन है, इसमें सेटिस्फाइड नहीं होगी। ठीक है ना?
यस सर यस।
वहां से आपने डायरेक्टली इसलिए 3 बोल दिया था ना सभी ने। इस फॉर्म की जब मैट्रिक्स होगी जो आपकी गिवन है ए, then you get, so here answer is 6. Clear?
यस सर।
तो अब तो नहीं इसमें कोई डाउट होगा किसी को, इस तरह के क्वेश्चंस आते हैं एग्जाम में तो सॉल्व कर लेंगे। बताइए।
यस सर।
We stop today's class and we start next class on, ठीक है? Okay.